Good day, viewers at home. This is simultaneous linear and quadratic equations. Earlier on, we have talked about quadratic equations, and then we have also talked about simultaneous linear equations. So this one combines both linear and quadratic. As you can see here, the first equation is linear and the second one carries power 2. So this is the quadratic part of the simultaneous equations. So when you have this kind of equations, definitely it will lead to the use of quadratic equation. But in some cases, we can avoid the quadratic aspect of it. And that is only if you check the quadratic part of the equations and you discover that it is a difference of two squares. You know, we've done something on difference of two squares before. X squared minus y squared is difference of two squares. And if you factorize x squared minus y squared, it will be x plus y, x minus y. And then the equation you have in equation 1, the left hand side, which is x plus y, must be one of the factors of this expression. So if x plus y can be gotten by factorizing this, then we don't have to involve quadratic equation. From this equation 2, we can see that this x squared minus y squared is the same thing as x plus y and x minus y equals 5. So this is what we are going to do. We'll factorize this difference of two squares. It gives us x plus y, x minus y. And from equation 1, we were told that x plus y is 5. So if x plus y is 5, that means wherever I see x plus y here, I can replace it with 5. So that gives me 5 brackets x minus y equals 5. Since 5 is common to both sides, I can divide through by 5. If I divide both sides by 5, here I'm left with x minus y, and 5 divided by 5 is 1. So I'll take this as equation 3. So with this now, we have avoided quadratic equation. We will now treat equation 1 and 3 as a pair of simultaneous equations, and then we can now use elimination method. This is x plus y equals 5. This is equation 1. X minus y equals 1, equation 2. So to use elimination method, we can just simply add equation 1 plus, this is equation 3. This one is equation 3. So equation 1 plus equation 3. X plus x is 2x. This is plus y and minus y. They will cancel out each other. 5 plus 1 is 6. So now we have 2x equals 6. So if you divide both sides by 2, 2 is 6 is 3. That means x equals 3. So we've gotten the value of x to be 3. Then you go back to equation 3 or equation 1. So we can start to use either of equation 1 or equation 3 to get the value of y. In equation 1, x plus y is 5. And our x is 3. So that means 3 plus y is 5. Y equals 5 minus 3. Y equals 2. So x equals 3, y equals 2. So this is when we can factorize the quadratic part of the simultaneous equations, in which one of the factors is similar to what we have in equation 1. But in a situation whereby it is not possible to factorize, let's just make a little adjustment to this question to understand what we are talking about. If you have x plus y equals 5, and then you have x squared minus 2y squared equals 1. From this now, this is no longer a difference of two squares, because Though we have a perfect square here, we have another perfect square here, but 2 is not a perfect square. That means I cannot simplify this the way I did previously. So for me to solve this equation now, I have to make use of the substitution method, and then I will end up arriving at quadratic equation. So from equation 1, we have that x plus y equals 5. That means x equals 5 minus y. We take this as equation 3. So we substitute 5 minus y for x in equation 2. We make x to be subject of formula here. So x is 5 minus y. So we now, whenever we see x here, we'll substitute 5 minus y for x. So equation 2 says x squared minus 2y squared equals 1. That means my x is 5 minus y. So I have 5 minus y squared minus 2y squared equals 1. So if you expand this, if you open this bracket, we'll get 25 minus 10y plus y squared minus 2y squared equals 1. So we try to rearrange to form a quadratic equation. So we collect like terms. Y squared minus 2y squared minus 10y plus 25. Then this one comes in. At the right hand side, we are left with 0. Y squared minus 2y squared, that is minus y squared. Then minus 10y, and this is plus 25 minus 1 is 24 equals 0. We can cancel this negative sign by multiplying both sides by minus 1, so that this will be y squared, this will become 10y, and this will become 24 equals 0. So with this, we have arrived at a quadratic equation. So we solve this quadratic equation. What factors of 24 are we going to add that will give us plus 10? For those of us who might not be able to factorize or know the factors, you can refer back to the previous videos on quadratic equations, how to factorize. If I take minus 2 and plus 12, I will end up getting plus 10. So it will be y squared minus 2y plus 12y minus 24 equals 0. So we pair them and factorize. Between this and this, y is common. Here I'm left with y. Here is left with 2. You bring down your sign. 12 and 24, what is the highest common factor? Remember, we always make use of the highest common factor. Because 12 and 24, 2 is a common factor. 3 is also common. 4 is common. 6 is common. But 12 is also common. So we are picking the highest of them, which is 12. So this is y. Then if I divide 24 by this 12, I'm left with 2. And don't forget that whatever you have in this bracket must also be in the other bracket. If they are different, that means something is wrong somewhere. So we have y minus 2. Then we pick one out of, we put these other factors in one bracket. Y plus 12 equals 0. Meaning y minus 2 equals 0, or y plus 12 equals 0. So y equals, if 2 comes to this side, it becomes 2. This will become minus 12. So now, since we have gotten 2 values for y, definitely we are going to get 2 values for x. So we will refer back to our equation 3. Equation 3. In equation 3, we have x to be 5 minus y. This is our equation 3. So when y equals 2, x will be 5 minus 2, which is 3. when y equals minus 12, x will be 5 minus 12, which is 5 plus 12, which is 17. So y equals minus 12, x equals 17. When y is 2, our x is 3. And we can give these answers in coordinate form. You know that x and y format. When x is 3, y is 2. And when x is 17, y is minus 12. So we can as well check in the equation to see if these values are actually correct by putting them back into the equation to confirm. Thank you.